Welcome to another version of the Ars Electronica home delivery, again from the main gallery in the Ars Electronica Center and from an exhibition, a part of an exhibition called Global Shift. We are standing in front of our elevation model, which shows part of Upper Austria. And today's topic will be false color images, false color satellite images, and we are especially concentrating on false color satellite images from the pair of sentinels called Sentinel II, 2A and 2B are up there, and they are doing high-resolution images in 13 different channels. What you see in the back here is the Alps at the lower part, then you see the Upper Austrian lakes, and Linz is in the upper right corner. And at the moment, the color combination is 4-3-2. All those three channels are in the visible range of a human eye, so you could see those channels with your eyes. But it's only almost natural. It's not naturalistic because all three channels are very distinctively defined. Every image is always RGB, red, green, blue. And as I mentioned, channel 4 is under red channel, and 3 and 2 are on green and blue. And if I can change the view now and switch to another combination. And if you look at the clouds down here on the Alps, you'll see it is the same picture. But it looks very different. I'm going to explain why it looks different in a minute. And the other picture is again the same image, just another color combination is used. Switching there and back again. And if we go to the last version, you see that now at the moment the clouds are white, but the glaciers are blue. This is a thermal image. Further explanation will follow shortly. But you can already make out the difference between the white clouds and the blue glacier, which is not visible if you use natural colors. So let's start with the so-called vegetation image. Now there is a channel in the near-infrared spectrum. Near-infrared spectrum is very close to the red we can still see with our eyes, but it is invisible to our eyes. And in this near-infrared spectrum, chlorophyll, the green part of the plants, reflects the sunlight almost 100%. And as long as spinach has a different color than salad in the visible range, it also has a very different line of spectrum in the near-infrared part of the spectrum. So an expert can not only tell you what is growing there. Of course, you would have to zoom in a little farther, and then they could tell you, okay, this is corn, and this is beets, and those are strawberries. But as always, you need confirmation from the ground, so-called in situ measurements. For example, you see a red dot there, and then you send someone in, and this person tells you, okay, those are strawberries. Then you can imagine that everything which has exactly the same red color in this image are also strawberries. And you also see the stress of a plant, because if a plant is very stressed, then it reflects less. So you have a white spot in there. So, but you don't know why the plant has stress. So again, you need to send someone there, and then they come back and tell you, okay, this corn has some kind of disease, or bugs pestering it, or this field is very, very dry, or it's a meter underwater. You can't tell that from this kind of satellite images. Of course, with radar, you can, for example, measure droughts or floods, but not with this kind of optical images. So whenever you see a very red optical image, most of the time it's done for vegetation, but that's just per choice that it is red, because the near-infrared channel is on the red, in the red part. But if you would go there and place the same, in this case the channel number 8, on blue, then the image would be very blue, or you could also do that, place it on green, then it would be very green. Okay, we are now switching to the next version, which we already had a little bit. Now this is a channel combination 12, 11, and 4. And 12 and 11 are shortwave infrared channels, and shortwave infrared is something with which you can measure temperature. As is very visible over here, the cold glaciers are blue. The clouds are not as cold as the glacier, that's why they are white. You can also make out that the cities are more yellow than the surrounding countryside because they are warmer. And if there would be a fire in there, it would be bright orange. And that's exactly what we are going to look at in another table on the other side of this exhibition. We are now looking at a fire in California in 2018, and at first you have the natural color image, and you see the channel combination 4, 3, 2 in the back. And here we are able to zoom in, and you see the channel combination 12, 11, 5. It doesn't make a big difference if you use the channel 5 or 4, but if I zoom in over the fires, you can see them very much better than you would just using the natural colors. It took quite a while till some visitors of the museum found that there are 2 tiny, tiny snowfields in this image. You can see them up there. The tiny blue spot, those are snowfields. And if someone would zoom over to the cryosphere screen. This is what the parts of the Karakorum look like in winter. At the moment you see the natural color image, and this is using the channels 12, 11, and 4 again. Of course, you could use all kinds of different channels. And here we have another example. At this screen, the topic of this screen is atmosphere. And sorry, what we got here is an image of a Vesuve in Italy. Natural colors Next version, if it's very red, it's again done for the vegetation, using channels 843, and now you can see the fires. This was again a thermal image. In the vegetation image, can you see the black scars? The black scars come from fires which were burning on the Vesuve in summer of 2017. The Vesuve was not erupting. I don't know why the fires broke out, but that had nothing to do with a volcanic eruption. But you can clearly here see the burn marks, and in the next image you can even see the flames. If you want to test that for yourself, there is a program called Sentinel Playground, and Sentinel Playground is a website, and this website is available for free on the internet, and there you could play around, because on the very top on the left side you can see custom, and if you click on that you get the 13 different channels, and then you can just pull them over RGB and make your own experiments with this program. Below Sentinel Playground there is Google Maps, so every little village which can be found with Google search can be found with Playground, and there are always the newest Sentinel II images on top. And yeah, you can experiment with that yourself. So this was an excursion of the false color images of Sentinel II. Of Sentinel III is taking images in 35 different channels, and you could also experiment with all 35 channels in a program called EO Browser, Earth Observation Browser. I didn't bother too much because handling 13 channels is enough. 35 is a little too much for me just as a hobby, but if you want to try that, you could do that on the internet, because all the data is free. And if you have an idea what you could do with all the images, well, like creating your own clothing, for example, this is an image I did myself. You can download the data from the internet and do whatever you want with them. So with this, I'm ending this short home delivery today. Maybe we'll dig deeper into the exhibition in the next coming weeks. So thank you for your attention, and hope to see you again soon.